So, hello. This is was going to be a presentation and some demoing and live coding of Praxis Live. For similar technical reasons, I've moved my slides onto USB stick and there won't be any actual live coding demonstration, unfortunately. I am doing, this is going to be kind of an extended State of Libre Graphics about Praxis Live then with some slides. However, there is a workshop tomorrow morning as well, which is slightly an advertisement for. So hopefully if you're interested in looking further, you can come along and we'll go through some of those examples that I was going to show today then too. So, who am I? I'm Neil C. Smith. I'm artist and technologist. I live in Oxford in the UK. I worked for 10 years doing kind of web consultancy work for cultural charity sector, prior to which I'd worked for 5 years doing culture and local government. So a slightly eclectic background. Spent 15 years making various creative applications in Java, various kinds of interactive projections and performances. So I'm now freelancing, doing various things around open source Java technologies, particularly media-based and graphics-based. So Praxis Live, as part of that, so doing bits of work around GStreamer bindings for Java, audio utilities, and getting involved with the Apache NetBeans IDE. When I'm not coding, or what I'm coding for sometimes, is creating audiovisual performances, generative, interactive spaces and projections. So this was an interactive audiovisual instrument which was capturing movement in a space. Projection mapping onto an old chimney space. This again was interactive, where faces appeared in the smoke and followed people around the room. Whispered lorem ipsum at them, which is one of the scariest things you will ever hear. So this is a projection piece for a public square, actually in Oxford itself. We had 2 camera booths, 2 infrared cameras, one on either side, where people could interact with scenes and each other projected on a building. And then the other end of the scale, so that project and this one were created in collaboration with someone called Naomi Morris, who's a dance and video artist. And this is a quirky take on a magic lantern, which actually had a little Intel compute stick and an LED projector and RFID tags in the slides. More recently, I've got into doing live coding, mostly audio stuff, some graphic stuff. And particularly, so taking IDEs into nightclubs in Athens or scary mornings in Poland, talking to 800 Java developers. Okay, so try to cover, if you saw me talk about this in London, try not to cover exactly what it is, but some of the things that have happened since. But Praxis Live is a hybrid visual IDE for live creative coding. Obviously, I'm using it quite a bit for live coding at the moment. It's not specifically designed just for live coding, and that most of the projection work you saw was created with it. It is as much about having an interactive environment for kind of creative work, installation, graphics, creative flow, that sort of thing. And it's as much a runtime as an IDE. You don't have to use the graphical aspects of it. You can build self-contained applications with it. That sort of stuff, which I've talked about. So this is what it looks like. This is what it looks like now, actually. It's had a little bit of a revamp in the recent version. I added Bezier curves to the graph. I've had so many features over the last year. I added Bezier curves, which took 2 hours, and that got the most interest of anything I've done in the last year. So what you see here is it's an IDE that mixes node-based interface and code. Any single one of those nodes is backed by code that you can live edit. So the runtime has an embedded Java compiler. So we're talking about something that you can recode anything that it's doing. So key features: intuitive graphical patching, we can basically extend it as much as we want as it's running. So built-in support for doing things with OpenGL, GStreamer, Jack Audio. Built-in support for binding MIDI OSC UIs or physical computing, so things like, I do quite a lot of stuff, that Magic Lantern had Tinkerforge, which is open hardware. So there's Tinkerforge support built in, but any sort of open hardware sensors and things, it's easy to integrate that and link it to anything you're working with. And ability to create standalone projects, cross-platform. And finally, since when I last spoke about this, it wasn't running on the Pi. It now does run on the Pi. It's free and open source, built on top of many great projects. It's not, it's kind of, I was talking to someone that, yes, I'm in many ways the only developer of it, but it brings together, it's much about joining the pieces together. So it can work with anything that runs on the JDK, but particularly comes with built-in support for processing. So any of those nodes in a visual graph is basically a processing sketch that you can live edit. Built-in support for GStreamer video, built on top of Apache NetBeans platform and IDE. Some of you may know NetBeans as in just NetBeans. It was donated by, so it was Sun, then Oracle. They've donated it to the Apache Foundation, which I've recently got involved with as a committer, and it's an interesting process. Very different. Alt-Tab now. That was going to be the bit where I showed you some live coding demos. That might be less easy. But I do have, never done this before. So last minute, I have moved a video of, where are we? Where's up? So whether this will work or not, we'll soon find out. But this is a video of the talk I was doing in Poland. I'm just going to skip forward a little bit to give you some idea of some of the things I'm talking about. Possible. What's that mean? Can I click that?
Hello, hopefully this microphone's working. Okay, we've had a few, just about says it, yeah.
Where did that one go?
Private example. Busy doing this and trying that we can do examples for this talk. One quick example. So earlier I showed you a Pharaoh example that was on screen of them live
Just about
coding
hear
some
me
visuals.
talking in the background.
I found that last week while I was looking for some examples for this talk. And I thought I'd see how easy it was to recreate this. So
the bit you just missed was me saying that was, I was looking at various other sorts of live coding environments and creative environments. That particular example is ported from Pharaoh, which is a Smalltalk environment. This is one of the graphics examples that we...
Here we have, let's just zoom that in a bit. So again, something we can play around with. Maybe we'll do something.
So what you may or may not be able to see...
we can start making some interesting...
Shut up.
Visualizations.
What you may or may not be able to see is, it's a bit smaller, but that's a very simple processing sketch. So just the draw method processing sketch, which is one of the nodes within that graph. And every time I hit save, it's recompiled and immediately, so all the state is maintained. So we can quickly and easily build up simple geometric things that kind of look interesting. I don't know how useful they are, but they're fun to play with. So that was taken from one of the Pharaoh examples. Then I had the feeling I wanted to try this in 3D as well. So to echo what I just said,
version of the same thing.
Then started playing around with this in 3D. So obviously you've got 3D OpenGL support as well, and working with that. The one of the things that's been added since I last spoke about this is the ability to pass any kind of arbitrary binary data around a graph, between graphs. So where are we? So I was doing. So you can have multiple graphs running at any point. So there's an audio graph and a video graph here, and just sending FFT data back and forth in order to
The point of live coding is to do it with time. You want something to happen at a point in time. Building block, but it's, yeah, that particular API is a good thing to use generally, but is not necessarily so quick and easy to put together when you're trying to play something immediately. So in this particular component, I just built up some simple forms that use these clocks and filters, do various things around indices and things. And then we can instead do something like
sending audio, the data there, and key data into the data.
So we've got a sometimes which says maybe do this.
There's been a lot of support. I know this is the graphics conference. There's a lot of support for doing audio DSP live coding and sequencing.
Okay. Cheating time.
Yeah, that was a seamless fade there. All right, and stop. So, good thing about that was I didn't actually have to try and do that in front of you, but that's where the fun is. So, history of this as a project. It actually dates back as far as 2011. I started as a project. I was building various things just as a kind of repository to throw some code at that I was reusing all the time and building. So that originally was not processing based. I'd got my own OpenGL pipeline in there, and there's very limited support for adding custom components and coding. So the whole thing was basically extensively rewritten with processing added and this ability to recode anything in towards the end of 2015. So that was kind of the state you saw it if you were in London. Version 3 in 2017 added support for Java 8. There's quite a lot of, which you won't get in sort of standard processing of using functional programming where possible. Processing 3. Siphon and Spout support for sharing textures if you're on Mac or Windows, and it's really annoying there isn't an equivalent on Linux. Support for the Pi, support for adding third-party libraries in, which is great. There's, okay, back to, here's the unprepared bit. So that's, right, that doesn't do F11. So I added, this is one of the examples I wanted to show you, but in terms of third-party libraries, this was bringing together various things. This is HE Mesh, which is a processing library. Very interesting for doing geometries and things, and using, so what I was doing there is actually doing things with geometries and then bringing in video textures and shader textures and things into that. You can quickly and easily patch between and work with. And also mouse responsive, so that was something that's been added, that is actually keyboard and mouse support. And then most recently, which was meant to be finished by now, but you know it's almost there. If you're coming tomorrow, you get the release candidate to play with. Fuzzy Connections, yay. Much more focused on recoding anything, so there are a few components that weren't recodable, so there's been a push to kind of get everything to be recodable, and also a push towards being able to recode with anything, so generic data paths and pushing any sort of data, vector data, that sort of thing through building components. And as part of a kind of way to see about building user base and making it a bit more sustainable project, the core runtime, so there's an IDE and there's a runtime, which has always been slightly separate, but more of a focus on that as a usable thing and relicensing it under LGPL. So Practice Live is kind of built around, so Andrew Sorensen, developer of a project called Extemporary, talked about cyber-physical coding, but it's the idea of real-time programming of real-time systems, which is kind of a big influence in terms of where Practice Live is and is going. This idea, user code as a first-class citizen, you know, turtles all the way down, that's a phrase you know, but the idea that it's not a node system that has a load of native components and a scripting language, and if you're having to create custom functionality, it's running in slower or something like that. The idea is the entire stack of this application. You can go as deep or as high level as you want. You don't have to code at all. You can code very low level. It's up to you. And that goes down to, so on the audio side, being able to code sample level DSP and play with filters. That's that sort of performance level up to patching together video components and filters very easily. Without getting too technical, but it's based around a sort of forest of actors architecture. So actors as in programming model. So we have a graph of components that are running there, which you patch together as you wish, but you can have as many graphs as you want. So different video patches, audio patches, whatever. So there's built-in support for communicating between them. And various sort of black box services that are part of that, so live compiling or background resource loading, background loading of images. And then with the same thing, we can then split that across different processes or different machines. So it's quite possible to have the IDE and bits of a project running on one laptop and something running on another. I know a few people have used that. Running things in multiple processes. Me doing real-time stuff on a JVM gets criticized occasionally with a certain thing called the garbage collector. But actually it's one way of mitigating doing some real-time stuff is to split things across different processes. And then so running on a Pi, so it's possible to have a project running on a Pi or a group of Pis and control them all from a laptop. And if you're, say, coming from a processing background, processing what's Practice Live give you above PDE, real-time live programming. Multiple sketches, so it wraps things so it feels like you're programming a sketch in every component. Lots of pre-built things that you can use as a basis. Built-in support for GStreamer 1, which is coming, I think, in the Preston Video Library soon. Blending fixed. So I extended the processing pipeline to use pre-multiplied alpha because they have I don't want to get into the flame war of whether you should or you shouldn't, but processing mixes the two. So you start compositing down a whole graph chain of things and it goes wrong. Various things around resource management, so loading images, caching things. Also in terms of if you have a long chain of operations, it will reuse textures from before and work out what it can copy and not. Threading and distribution done right, so this idea of being able to pass things lock-free between a background process that's talking to the net or audio or sensors or whatever, that's all built in and you don't have to think about. Built on top of a professional IDE, so it's all built on top of the NetBeans platform and IDE. Lots of added things included, and the one thing that niggles me about processing is claims of floss but running on not supporting OpenJDK properly. So that's one thing I'm definitely doing. And in the Windows and Mac installers generally use OpenJDK. What might you build? So I thought I'd just share a couple of images of things that I found that other people have made. So Max, who unfortunately couldn't come, was going to be coming and talking about another project called Freeliner, which is a mapping software. But that's him. I'm not quite sure where that is, but he's using the distributed hub. So he's got the video project actually running from another machine, projecting in a nightclub, I think, doing things with live graphics. And then, nice setup with 2 screens to be actually editing that and working with it live. That's one of his things, mixing Practice Live and Freeliner together. Some other images. Hopefully this will. It's a nice video he sent me last night, which I tried to put into here. This might be a bit loud, actually.
Okay. No! It's not very nice!
So really nice visuals anyway. Sounds a bit. Matthias I met doing a workshop in Tübingen for Generate in October last year. So he'd done a lot of work with processing before. He made good use of Tinkerforge are German, so it's kind of patriotic thing to do, but he made this excellent setup with a load of Tinkerforge components to control his processing sketches via Praxis Live. He's doing really beautiful things, lots of monochrome things, and this is using luminance of a video file to manipulate and mash up lots of still images. There's the Punkamat, I think it's punkamat.de, or his Instagram. There's a lot of videos of his stuff. It's really nice. Lots of simple 3D, really effective tunnels. And then I had a great interaction on the Gitter support, which I've just set up a couple of weeks ago. The guy's name I do not know. I just know that's his Twitter handle. Who had a little bit of support, had a little bit of experience turned out later with working with Ruby, but hadn't used any Java before, not used Praxis Live before. And in about 2 weeks, he was doing his first VJing setup, and he built that. So that's with the UI builder, controlling, working with shaders. It's probably one of the most impressive UIs I've seen someone build in Praxis Live, because I don't tend to use it. And definitely for someone who'd only been using it for a couple of weeks. And so he's on a Mac, so he's able to use Siphon to bring textures in and run like preview windows and things, but he built that. And that's on GitHub as well. Let's put it up. A few nice things people have said. So the guy who made the VJ thing was talking about how just speed of developing anything with it was he really enjoyed. Okay, so that's really why I'm speaking. Tomorrow morning, if you want to have a go, you want to see some more examples, workshop slightly early maybe, 10:30, not too much beer tonight. And thank you. Everything is on GitHub. I know someone questioned that at some point in the mailing list when I applied to talk. So the Praxis Live website, all the sources there. If you want to come and get involved, have a go, talk to me, it'd be great. Any questions?
One question about the Siphon stuff. You said that's on Windows and Mac and not Linux. What does it do exactly? Just grabbing texture from another window?
So Spout is the Windows equivalent. Siphon is on that, so the support. They allow direct texture sharing between processes.
Okay, but how do other process share that texture? Is it something that depends on the other software also, or?
Yes. So you basically, it's like I think it's like a client server. So something that sends textures acts as a server, and any client can connect to that, and it just gets pumped a texture.
There's really no way to with X to get the X.
Not as far as I'm aware. I've seen or been involved with loads of discussions with people, and lots of people who. So there's a number of groups who are pushing Linux as a Libre VJ platform who are really pushing. I mean, I'm not a VJ. I just happen to write something that some VJs quite like using. And I know there's been.
So we need to have a new protocol like that in Linux to support
Potentially there's something coming. Is it Pipewire? Pipewire, I think it's called. Which is one of the guys who really set up GStreamer. So it's a little bit kind of trying to do for video and for audio. So like equivalent of Jack for audio, but also for video. And I think there might be a possibility that it will allow texture sharing. I have a vague feeling from things I've seen in the GStreamer mailing list that there's something in there that would allow it now, but it feels like a bit of a black box.
So from your perspective, what layer would that optimally be implemented at?
What do you mean?
So in the
To do
software-
texture sharing?
Yeah, the texture share. Like, should that be in the OpenGL part of the stack, or higher, lower?
I don't know.
Okay.
There's a simple answer to that. And I think it will change. In terms of what the OpenGLs you're using is, because I think GLES might have some functionality for that anyway. But
Pipewire is a lot also about these container-based things like Flatpak and Snap and app images, where you isolate the applications and then you want access to webcam or doing things like sharing media things or getting access to the media devices. Because the way things normally done on Linux is that you directly get access to the webcam from the application, but this provides an API requesting texture data from the webcam.
okay, thank you.
I think I'm ready. Oh, the one with the red light. That makes sense. Hi. So I'm going to give another talk about nodes in a very different context, I think. This is not laid out live. It's not live at all, or at least the node stuff. It's not meant to be real time. So over the last many years, node systems seem to be popping up more and more in all kinds of different applications, including open source. There's some proprietary stuff that's at least deserves a mention, even though this is the Libre Graphics Meeting. There's nodes like Praxis, and the Godot game engine has a node system that seems to operate very similar to what Praxis is doing. Blender is probably the most widely known one for the node system that it has. Blender is, seems like Praxis and Blender are both quite good because it's very extensible. It's very easy to add extensions. If you have a node system that doesn't quite do what you want, then you can construct other nodes that do what you want. Let's see. I have a lot of friends who are artists who don't think like programmers, and vice versa. And nodes are kind of a middle ground that let artists mess around with stuff that's normally the domain of programmers, and programmers get access to like much more immediate visual presentation. So it's kind of an uneasy middle ground. So sometimes you end up just messing around with little boxes, spending too much time messing around with boxes. So for instance, there's one site called Blueprints from Hell, which gives great examples of misuse of nodes. These are from the Unreal game engine, where nodes are called blueprints. Then you can browse the Blueprints from Hell for many examples, gigantic messes like this, or things that sometimes there's like a box connected to like 50 things, and then it's connected to another 50 things. So if you're gonna make node systems like that, you might as well just program. So it's kind of comes back to the uneasy ground. Artists might not really understand programming, so they take these tricks and then end up with stuff like this that could be much simpler if you use code. Another system that's at least deserves a mention is Substance Painter, which has a very extensive node system. It's proprietary, but just as an example of what you can do with nodes, with like enough node bases. Many of this stuff you can do in Blender too, but it's kind of a little more fiddly. So like just with some node systems, you can take one source and then divide it into different aspects of a surface, and then do stuff to it and do some branching, and then the nodes kind of come back together, and ultimately you end up with just a surface that you can apply to any model. So, and here's just a flash of how nodes look in Godot game engine, which looks remarkably like Practice in many ways. And so it's not just for like 3D and animation. I've been trying to figure out how to use nodes in a more two-dimensional context. So for instance, this is basically 2 dimensions. There's just a plane in the background. This was made in Blender. I forgot to pack the actual file, so I can't show you the node setup. It's basically just what's called a flow map. So you have some nodes that it's like if you use the iWarp plugin in GIMP, you define a field and you're just shifting pixels around. That's basically what this is doing. You define a flow field and then sample it at 2 different points in time, then sort of blend it together, and you get a more or less continuous looking motion. And the nodes for this, there's maybe about 10, 15 nodes or so. It's not a very complicated node setup, but you can end up with some moderately nice looking stuff. Let's see. The core of Blender is not so adaptable in some ways. For nodes, you can use nodes to make textures, and you can use nodes to make compositing, and then compositing is more the traditional 2-dimensional image creation methods, and the materials are more pertaining to like the Substance examples, 3-dimensional models, and basically skinning those things. Let's see. However, since Blender's nodes are very extensible, there's systems that people have developed to do some pretty sophisticated stuff. For instance, this is by Jacques Luc animation nodes, which extends Blender to be able to manipulate geometries and sets of points and repeat things along points. You can do some pretty interesting stuff with that. Another node system that also works in Blender that does similar things is called Sverchok. You can do lots of strange geometry, and that's a little more tailored to kind of architectural applications and procedural like structure deformations and things like that. And this is an example of something done with animation nodes. I figure if you're going to destroy a big building, you might as well do it with a giant insect. And then so the nodes for these, I did pack that. I wanted to do a comparison. So if you try to make like a building, you have a lot of repeated elements, and computers are supposed to be able to do tedious things pretty easily. So I wanted to compare, okay, so if I'm going to do this with a script, how does that compare to a node setup? So like this was the node setup to do all of those, all the building creation. So like you're starting from a couple of window objects, and then all of these nodes are taking that wall and repeating it along one facade and then moving it around so you get 4 sides of the building. The actual exploding part is just like a few nodes at the end. So animation nodes makes it very easy to do some operations, but it's a little more difficult to do other operations. So all of this stuff is just a big mass of complicated stuff that's much easier to do with coding. So which is more complex? I think it's kind of debatable maybe. So the equivalent of that is about 500 lines of Python. It's probably unoptimized Python, so you could probably do it faster, but my version was 500 lines of Python or this, which is really more complicated. I don't know. In terms of maintainability, it kind of depends on who's coming back to maintain it later. If you have people who are maybe less interested in learning obscure syntax rules, maybe they can dig into this, assuming that it's like properly documented. Blender has these frames that you can put around things to add extra documentation. Let's see. So even though like in Blender, most nodes are geared for 3-dimensional use, in terms of 2-dimensional image production, it's an easy way for artists to create something and then cycle through a bunch of different variations and then pick something that they want. Or they can save node systems to define kind of a general style that they want. Then like if you're making a comic book, you have 100 different scenes, but you might want a slightly different weather or a slightly different building materials or something in it as backgrounds. So it's much easier just to have just a library of stuff you can immediately apply to it and then kind of squash it down. So there are applications that aren't quite live, geared for 2-dimensional production. That's kind of where I'm coming from. I've done a lot of comics, but over time, it just takes so long for me to draw. I keep looking for ways to make it faster for me to produce work. I end up spending a lot more time programming than actually making artwork, so it's not sure what I feel about that. It's kind of, there are trade-offs. In my own software called Layout, I've been trying to implement something that takes the best node practices from other stuff and tries to put them all into one place. And hopefully, since nodes are becoming more popular, figure out ways to use different node systems and be able to use them across applications. So for instance, here's another animation nodes example. It's the same sort of node setup, just like taking some pieces and just the simple transformation makes things kind of bug out. All right, so I've been working on this over the last couple of days, so I never quite know if these live demos are going to be quite what I expect them to be. part of the backbone I'm using for this node tool is using Gegel nodes. Gegel nodes internally are node-based. It's basically a C library, and it was shockingly easy to map the Gegel nodes into an interface, because you can query each property, and that usually has documentation. So it's pretty straightforward to map things together. See, one thing about nodes, like whenever you investigate node systems, oftentimes there are these big masses of mathematical nodes, like just simple things like adding and multiplying. When you write it, it's just like a number and another number, and you put like a slash or an asterisk between it, and it takes very little space. But in nodes, it takes a massive amount of space, which is kind of irritating. One thing in Blender that's missing is an expression node that would simplify these massive things of math. It would be nice to have like a compiler to take expressions and then map it out into nodes so that you could tinker with it that way, and then compile them down into expressions if that would be easier. I haven't quite implemented that yet, but that's kind of on my to-do list. See, another thing, when you download stuff off the internet, node systems, and you try to figure out what's going on, like in that slide before, it's often just a gigantic tangle of wires and connections, and it's hard to really tell what's connected to what. So I implemented something that lets you just click on a string, and then it automatically kind of follows it around. So it doesn't make nodes necessarily easier to use, but it makes it easier to figure out. And sometimes, like I mentioned before, maintainability can be a factor for reusability. So this node setup lets you change one value, and it calls some Gegel nodes and does a chunk of math below. And then this would be a very simple way to do animation using Gegel nodes from a node environment. And I have threads sort of implemented. It's like fake threading as soon as my menu comes up. So instead of being tied to a single value, you can do a loop. So now if you have this loop thing, it just can automatically process through Gegel nodes, and you can get some stuff out at the end. One thing with Gegel nodes is that sometimes the operations take a lot of time to do. So if the connections are secure, there are some nodes that save to files, for instance, the Gegel save. So if you change one value, it updates this whole node system and then automatically saves to a file. That's kind of irritating. So some nodes I put on extra properties to control whether something gets executed or not. So now if I run this loop, it constructs a file name. Come on, let me drag that out. I fixed one bug. This morning, it wasn't collapsing with the proper width, and I think I accidentally broke being able to expand the width of these nodes. But anyway, so now if I run this loop all the way, it creates a whole bunch of so it's now created on disk. So did I get all of those? Let's see if this works. So it's relatively easy to use these Gaggle nodes to make like simple stuff like this. It seems like maybe it's just because I'm not familiar with Gaggle nodes enough, but the built-in Gaggle nodes are very kind of basic. For like if you want more complicated gradients, you have to do something on top of the base Gaggle nodes. So in layout, I'm still trying to figure out how to make these nodes more extensible. You can, however, import existing XML. Gaggle can save and load XML files, and I wrote an importer to grab these XML files, which I would show you, but I tried it this morning and somehow I broke that too. This is very much a work in progress here with layout. Oh, another thing about nodes that's often kind of irritating, in terms of making two-dimensional images, it's important to be able to preview things step by step. So it's just kind of the visual way of debugging things, but oftentimes you can't really get at what the nodes are. So being able to preview things at different resolutions becomes quite important. With Gaggle nodes, each Gaggle node kind of does a process on an image, and some of them expect a certain rectangular image to operate in, and some of them don't. So sometimes if you connect Gaggle nodes here, it'll hang because it assumes a gigantic 2 billion wide rectangle. So sometimes you have to be careful about what area you're actually sampling. So you can kind of change, like this, the radial gradient creates something, but it's not technically bounded. You have to use another crop node to bound. So some of these nodes, instead of resizing the preview like that, if you hold down just modifiers, you can get a different view of what area in this image space you're sampling. So Gaggle nodes were one area external to layout that I'm trying to integrate. I've also been working on SVG filters. So this, for instance, is all of the Inkscape SVG filters that you can import and then work on a node basis. So I wrote a very simple untangler, but as you can see, it's not really untangling anything. It's just kind of, it's making it not overlap, but still doesn't necessarily make rational sense. And another feature that's I seem to have broken over the weekend is I wrote a Python extension for Inkscape so that within Inkscape, you can make something with a filter in it. Do I have that still running? And then you call this extension, and then that relays that SVG file to the layout node editor specifically, so you don't have to deal with the rest of layout, just the node interface that it processes so you can take the SVG filters that you might make in the filter editor in Inkscape, but then manipulate it as nodes, and then export the file back out. So it gets sent back to Inkscape. So it's potentially possible, after some debugging, to manipulate SVG filters with nodes. I'm still trying to figure out how to map SVG filters to Gaggle nodes, and then you could be able to have a live preview of what you're doing. That's not quite there yet. My to-do list keeps steadily growing, so I keep not making cartoons and instead hack away on this thing. So a couple of years ago, Peter Sicking gave a talk about node interfaces, and he suggested one thing that's, he was trying to simplify the node setup, which I'm not sure is quite what you want to cut off. But one thing that is kind of along those lines is being able to select specific properties within the nodes. Like oftentimes you'll have 50 nodes or whatever, but you only care about a few different properties. So I have plans to like make separate panels that you can hover off to the side or use in other parts of the program. And So you just manipulate those properties in a separate panel, and that relays to the whole node system, which updates and then updates whatever objects you're working on. And another integration with nodes is I'm trying to bridge the gap between like specific interface controls and node setups. So like there's an affine transformation to transform objects, but if you have other node-based stuff attached to it, this would be, it's almost a linear list. So if there were like a string of 10 node operations that are known to have specific tools associated with, like little widgets you can drag around, it would appear in this list up here, and it's not quite working yet, but you'd be able to like mute if a filter is operating or not. So this is just kind of a shortcut to get at different interfaces. You're not actually seeing a live transform, because I couldn't get that debugged before today. So many things to do. So this would be the node setup for that. It's just a very simple linear list. But since it's in a node arena, you could tie it to all kinds of other values to kind of drive different aspects to it. I had one that was just an affine transformation. Unless I broke it in the last half an hour. So if I get rid of these other ones. So now I can manipulate nodes here and have it be kind of a live update. Then I could later on put in other nodes, other filter nodes, and then those would show up here. And so you'd be able to get at the interfaces to manipulate stuff that's sort of controlled by nodes and sort of controlled by more traditional artist manipulations. So I have a workshop tomorrow, and if you're interested in talking about node interfaces, what you like and what you don't like, I'll have some examples of Blender, texture creation, and playing around with this stuff. A little bit of debugging session, perhaps. And I have a final slide here. Oh, it's more things on my to-do list is to take gmic and create nodes out of them. It's compared to Gaggle, gmic is considerably harder to figure out the individual pieces. I've looked at the GIMP implementation and the Krita implementation, and they're both equally dense to figure out what's actually going on there. So in time, I'll figure it out somehow. I also want to implement graphics magic nodes. Any system that has basically isolated operations that can be chained together. I'd like to be able to have some system that can more or less seamlessly translate between them. And sometimes when you crunch nodes down onto a screen, it's difficult to figure out what's really going on. So the obvious solution to that is to get rid of the screen entirely and do everything in virtual reality. So virtual reality comes with its own problems, so you have to deal with the natives there. And that's it. I don't know if there's questions. Any questions?
I have just a remark. Were you asking for SVG planning mouse or in Gaggle, as Gaggle, or what was it?
Oh, there's some Gaggle nodes that are specifically named SVG this or that, but I haven't figured out a way to represent all the different SVG filters with Gaggle nodes. So once I had that, then I could be able to live preview stuff within the node editor, all the SVG filters. But some of them there doesn't seem to be a clean map between the filters and Gaggle nodes that I can see.
Yeah, the SVG prefixes are blending nodes. I think the SVG blending nodes basically. So.
Those be implemented in RSVG or something like that? an RSVG or something.
Not sure.
And if there's no other questions, I guess that's it. Mitch?